I've always been interested in music. When I was a teenager, I started playing in bands and was very drawn to the equipment that we used. I ended up spending more time tweaking my amplifiers and microphones than I did writing songs and practicing with the band. So eventually I found my way into audio engineering. After school, I went to work for a company in California called AEA that specializes in making ribbon microphones.
I did my bachelor and master's in Ukraine, and then I did my double PhD in France and in Canada. And after completing the PhD, I went to Japan to make a postdoc. But then I met ORA guys. I was so impressed by and so much excited about this project, so I decided to leave the academia world and to join this startup. Application of graphene for sound to make the transducers of graphene is right the fit, because it meets all the properties which graphene possesses.
Really, the idea to apply graphene to loudspeakers came from an interaction between myself and my brother, and at the time he was working on graphene for battery anodes. He would mention the different mechanical characteristics that it had, and it struck me that these mechanical characteristics would be ideally suited for microphones and loudspeakers.
So when I first joined the project, it was really a few months old. Eric had filed a patent and made this prototype that looked ugly, but made some incredible sounds. So when I first saw the benefits of graphene, the battery savings, the instant improvement of sound quality, we immediately reached out to the industry and started asking who was interested. And really, everybody was.
Cell phone industry to hearing aid industry to laptop computers, loudspeakers are everywhere.
So while the industry was extremely excited about the tech, we really chose headphones because it was the perfect product to get it in as many hands as possible. One of the reasons why graphene hasn't taken off yet is because it's very hard to manufacture and it's very hard to form into geometries.
In our case, we have found a simple and yet efficient way to produce graphene sheets and to form membranes of graphene.
And there are other materials that have excellent mechanical properties like graphene. Many high-end esoteric loudspeakers will use beryllium or diamond as their speaker membrane. However, that's expensive to work with and expensive to produce.
It's really groundbreaking because for the first time ever, people will be able to listen to these incredible sound quality at costs that are not prohibitive to them.
At ORA, we aim not just for high power efficiency and for long battery life, but our target is really high fidelity of sound and accuracy of sound reproduction. It's all about the frequency response.
The difference is clearly apparent. We have done tests, we've done some double-blind listening tests. Everybody was immediately impressed with the sound quality of GrapheneQ over the standard Mylar membrane. So we've designed our prototype. We've designed the cosmetics and the acoustics, but we really need additional funding to move this out of the laboratory and into the factory where we can mass produce these headphones and bring it to the world.
So this is happening, and if you want to know more, keep updated in our Kickstarter page, follow us on social media, and learn how you could join the graphene revolution.